Hey everyone, we have already discussed about the bootstrap sampling, and here is a quick short video about how you can draw some bootstrap samples using statkey. A quick review of the definition first. We are assuming the original sample is chosen randomly from the population, okay, but we don't have the population anymore with us. The bootstrap distribution is generated by selecting sample of same size with replacement from original sample. The same original sample that we have, we'll use that same sample to generate more further samples with replacement, but keeping the same size as the original one. And what's happening, let's look at the process step by step. Generating a bootstrap distribution. First step, generate bootstrap samples by sampling with replacement from the original sample using the same sample size. Okay, then what to do? Compute the statistic of interest. Let's consider that we are interested in our average, and we'll use mean as the statistic, arithmetic mean. That statistic or arithmetic mean will be called the bootstrap statistic. For each of the bootstrap samples, the number of samples that we will draw from that original sample, for each of those we'll be calculating arithmetic mean. We'll look at that shortly, don't worry about that. Collect the statistic for many bootstrap samples to create a bootstrap distribution. So that's what we will call it, a bootstrap sampling distribution, not just the sampling distribution. Now let's go to the statkey and let's have some hands-on practice on that. Here we have statkey. If you remember the first section here, it helped us to figure out how the descriptive statistic works and how the graphs can be plotted for those. Then we have a sampling distribution for the means and for the proportions. If I'll go directly from here, I will reach at this section. And the thing that I want to point out here, this is where we were visiting and coming to get some different hands-on practice on population using these populations. And whatever we were doing, like let's select a statistics grade schools, and if I'll take 100 samples from here, what these 100 samples are doing for me, each of these dot is representing the mean of a sample from this population. You see, this is a population of how many values? There are 82 values here, and the mean of the population is 53. And if I will draw one sample of size 10, the sample will appear over here. Mark down the things. Here we have the population. Here we have the sample. And this is the last sample generated from these 100 samples. And here, this area, the main plot area, the sampling dot plot, if the means, is in fact each and every dot here is representing a mean of any of the 100 samples, one of the 100 samples. But I will not work on this while working on the bootstrap sampling. Instead of that, I will come here. Remember, this section is for the confidence intervals, and this section is for the hypothesis testing. That's our next topic. Now, quickly going through the bootstrap sampling, how to do that, and how we can fix the confidence interval into that also. We'll go for the first one, confidence interval for single mean or median standard deviation. I'll click on that. Here we are. We have a single sample. How this sample is selected based on this. It's a Mustang price. I believe it's an example from your book for the used Mustang cars. Here is the original sample of size 25. You see, now we don't have a population over here anymore. It's original sample. And from this original sample, we'll keep on selecting some values with replacement so that each and every value of this sample has equal chance every time when I will try to draw a single value. Let's try to do that. So here I got a sample, a bootstrap sample of size 25 from this sample. Notice the mean of this sample is 15.98, but this mean is not equal to 15.98. This is 13.84 because this sample does not have the same values, all the same values as this one. What we have done, let's say if I selected 11.9 from this sample, after selecting that, I put it back into the same original sample, and now it has all the equal chances as any other value to be selected again. So because of that, 11.8, no, we don't have 11.9 from that here, but 11.8 is selected 3 times. Here we have 11.9, and the other values also, somehow the 11.8 should also be there, which is selected, and here we have 11.9. Okay, 11.9 and 11.8 both are there, but here 11.8 is selected. Okay, somehow my mouse is moving, but make sure that all the values are not included here, and some values are repeated again and again, like this 9 is repeated around 5 times. And here is the single mean of this sample plotted on the dot plot. Now, if I'll keep on generating single samples of with the Bootstrap process, each and every dot over here will be representing a mean of a sample generated here. Let's plot 100 samples in one go, and looks like a distribution is in the formation. And this distribution will be called a Bootstrap distribution. Let's make our life easier. I'll draw 100,000 samples together. Now, how many samples do we have here now? 1,110. And look at that. The mean of all these samples is how much? 15.93, which is getting very close to 15.98. Now, this original sample, we have already considered that it's a true representation or a good representative of the population. So we are considering its mean as the population mean, not exactly as, but representative of population mean. So for this Bootstrap distribution, the mean of all means will get closer and closer to the original sample mean, which we will assume is the population mean. Okay, that's how we do the Bootstrap sampling. And quickly, I'll just put a confidence interval by selecting this two-tail test. Remember, 95% confidence interval we discussed in the class. 2.5% is on the left side, 2.5% is on the right side, and here we have the boundaries. The lower bound for this confidence interval 12.46146, and the upper bound is 20.481. Hope that will be helpful.